Hi, so I'm down at the Oasis, which is a housing unit that we have here at Tremont that some of our staff live in. And we're doing an energy audit to see how this house that was built in the 60s sizes up to energy needs and seeing what we need to do to make it more energy efficient.
Well, my name is Michael Dickinson. I go to Western Kentucky University right now on an internship with Oak Ridge National Lab. This is Caitlin Wood. She goes to University of Tennessee. She's also a student at the lab. We're going to do a pressure test today, depressurize the house to 50 pascals, hopefully try to get to 50.
What's that mean?
It's just the pressurization of the house so we can locate any air leakage from the outside in. We've got two different lines, one going to the outside pressure and one on the fan pressure.
So you've put this fan on the front door.
That's correct, yes.
So what's it going to do?
What this fan's going to do, we're actually depressurizing the house, so it's going to suck all the air out of the house. And what that's going to tell us is we'll be able to walk around with our smoke and go check things like the stove. We'll be able to check windows and see what kind of leaks from the outside in are.
And what's this fancy gadget that you got hooked to the computer?
This is the manometer. This is what measures the pressure change. And we've got it hooked up to our computer, which does all the calculations. The computer takes 200 measurements, and it's going to give us a value of an air change.
Cool.
It's going to plot a graph based on the points.
Say that again?
It's going to plot a graph based on the points at different pressures and different air changes, so it can plot the leakage of the building.
So, tell us what you're finding there.
Right now, since we depressurized the house, it's trying to equalize itself with the pressure on the outside, so it's sucking in air from the outside. Okay. And what this is telling us is that you've got some serious leakage here. It's that seal shot right there on the window, probably. Same thing on that one.
I'm Jeff Christian. I'm a researcher from the Oak Ridge National Laboratory, and we're here in front of the Oasis house doing a health checkup. And we hope that this will be one of our 10 extreme retrofits that we're doing around the East Tennessee area. What we've just completed was a blower door test. We pressurized the house looking for all the leaks through the windows and the walls and the ceilings, of which we did find quite a few. And then we also tested the air tightness of the duct system, of which that had been recently done. That's in pretty good shape. So what we're here for, we're going to give this a ranking. It's called a home energy rating, from 0 being a zero energy house to like 100 if it were a new house. And then we're going to do a nice retrofit on it, add insulation, add air tightness, and change the windows. And then we'll test it after that, and we should be able to predict. And what I'm hoping from what I just witnessed is that we should be able to get about a 35–40% energy savings out of the Oasis house.